As I mentioned in our first lesson of this chapter, Ton has a rapidly growing set of programming tools. And sometimes it just doesn't make sense to create your own custom local setup. And there's a great one worth mentioning. It's called Blueprint, and it's maintained by Ton Tech team, officially supported by Ton Foundation. Deploy process is also very much simplified with Blueprint. However, we are still going to create our own custom deploy script so you would better understand the logic behind it. We're on the finish line. Believe me, if you've made it this far, I'm more than sure that you are going to become a Ton contract developer. It's an honor for me to be the person who's actually onboarding you in this process. So far, we've built our compilation and testing suites. But just like satellites are meant to be in space, smart contracts are meant to be on chain. So let's go for it. You've already heard of testnet, which is a separate network meant for testing all possible things for developers. And testnet operates with test Ton coins. Those are not worth real money. So you don't need to buy them. You can easily get them from the official testnet giver Telegram bot. Initially, we are going to deploy our contract to testnet. This bot will ask you for your address. So you need to have a wallet that would operate with test Ton coins. You're probably familiar with wallets like TonHub or TonKeeper. TonKeeper has testnet functionality embedded inside, while TonHub has testnet functionality separated into other mobile application called Sandbox. You can use both Sandbox by TonWhales or TonKeeper, but for example purposes, we're going to use Sandbox made by TonWhales team. It is available for iOS and Android, and you can easily download it to your mobile. The links are in the attachment. Once you have installed Sandbox and created a wallet, then you can get an address to receive testnet coins, and you can use it with a Telegram bot test giver. So now let's create a new file in our scripts folder called deploy.ts. As you remember, to deploy the contract, we need to calculate the future address of the contract. We compose an initial state of the contract, the code and initial data. We compose a message that will carry the initial state, and we send the composed message to the future address of the contract on blockchain. So here's what our deploy script will look like before we actually send the deploy message. So let me create the deploy.ts file. So we are going to have a async function again called deploy script. And we are executing this async function. And here is the first part of our code that does exactly the first step. So we are calculating the future address of our contract. So we need to import important primitives. We import the cell class. We need to import our code. As you remember, we have it in our main build.js file, build.ts, from build. Main compile JSON. And we'll also learn about new class, new interface type. We need to import begin cell. And we need to import function store state init. And of course, contract address. So we have all imports ready. And let's learn a little more about what happens here. So we are already familiar with all the types here except the state init, I guess, and store state init function. So store state init is provided by Ton Core, and it helps us to actually create a cell that would have state init inside of it. And the state init itself, it's just a few parameters and some data that are going to be the initial state of the contract. That's why I call it state init. For now, it's important to know only about the code and data that is inside there, but we will see a bit later what else could be consistent there. So an important concept that is used here with state init, and we will have to learn about it, it's builder. So builder is basically the functionality that helps us to build a cell. So as you can see in this code, we are creating a builder with function begin cell. So function begin cell is returning a builder. And then we use function store state init that is actually accepting state init object. So as you can see, the state init object is just a, let's say, TypeScript object with certain data. And the most important for us now is the code and initial data of the contract. And basically, this function is accepting state init object and returning builder. So we also have to provide a builder for the new cell. So we basically just execute this builder with this function with this builder. And the result of that is going to be obviously updated builder that we just opened here. So the only thing we need to do to get the finalized cell is actually end cell. So end cell is executing on builder and it's finalizing it into a complete cell. And then we use function contract address to calculate this address of the contract. So we compose the cell with initial state, and then we calculated the address, the future address. It's not dependent things, but this is something that we will need for next steps. We could achieve the same results by manually constructing the cell. So, as you know, we already, as you learned the concept of begin cell that is returning builder, we could manually go bit by bit and actually store data according to the supposed structure. So you can learn about this in the documentation, but I'm just showing you as an example that TypeScript libraries, TONCore, like there is more libraries like that, they're simply there to actually help you to get away from the very low level things like composing the cell, because this cell is composed quite often and you will not need to do this manually every time. Very often you will compose the cells by yourself, but this is going to be your custom cells where you define the structure, and then your contract knows how to read it because you programmed it, right? But at this moment, so basically you see that there is one bit for split depth. So these things are not even at the moment important for you because you don't want to get lost in these primitives. But here is like important that we actually put the cells, we kind of put the references to another cell. So in one cell, we can have some information as bits or some references to other cells. So it results as a tree of cells. You probably heard of that in first chapters. Okay, so I'm going to remove this thing because we're not going to use that low level, but this part is just doing just the same thing. So in order to send a message, we are going to need the Sendbox wallet that you've installed in the beginning. Sendbox has cool API that enables deep linking into the wallet and TonHub as well. So meaning that we could compose a link that would have all the parameters needed to send a message. Then we open this link on our mobile and it will redirect us inside of the app and actually request a transaction. So we will have to confirm the transaction of sending this amount with certain data. And next step, what we're going to do, we're going to compose this kind of link, then create a QR code out of it, and then show it on the terminal. So we could scan it with our mobile. So we're going to install a few more libraries, especially one important for now is the query string, because imagine we have code and data stored inside of the initial state cell. So we have a whole cell that we will need to stringify into the base 64 format So basically, we'll have the amount of money that need to be sent because it costs money to deploy contract. On testnet, obviously, this money are not worth anything, but in real life, you will need to send some money, some coins. So you would basically put the amount, message, and optionally, you could put the initial state of something. So this transaction would mean a deploy of the contract. Let's install another library that is going to help us to show QR code in terminal. So we would pack this link into a QR code so we could scan it from our mobile. So with help of those two libraries, we are actually forming a URL. First, we need to import them. Also, we need to import the 2nano, and we need to import the QR code library. So now we're good to go, but let's have a look here. So we could also send much less money because the whole 1 TON coin would be too much for deploy contract, unless you want this contract to be deployed and have some extra money there. But we'll put there just enough to deploy it and have a little bit for the future costs. So basically, we're using this deep linking for TonHub. TonHub and Sandbox, don't get confused with that. It is the same application, but Sandbox is for testnet. So we are using subdomain test to actually form this link. So here we put the address, future address of the contract, and we also put the message, we put the amount, we put the init state, and as you can see, we are actually taking the cell, we put it as a body of cells, we serialize it to the body of cell, and then we actually stringify it in base64 format. And then we are just packing this all into a QR code. So I'm going to save it. So just like we did in the previous lessons, why don't we just add some informative console logs so our script would make more sense while it's running. We would know the state of it. So we put the deploy script is running when it starts, and then let's put some console logs after we know the address, the future address of the contract. So we say this is the address, and please scan the QR code below to deploy the contract. So let's go to package.json and create a new script called deploy, obviously. And we are going to, again, compile it just to make sure that no changes are actually lost. And we will run the scripts, deploy TypeScript, and run it with TypeScript node. Great. So now we can easily run yarn deploy. So what we're going to see now is going to be a QR code. Yeah, it compiled, and now we see a QR code. I'm opening application Sandbox on my mobile, and I'm using scanner to actually scan the QR code. You can see that our message deploy contract, we see the right amount, and we are signing the transaction. So once this transaction is going to be finished, we can actually open the address in Explorer. So transaction is sent. We expect our contract to be deployed. At this point, we are heading to Explorer. There's multiple explorers, but I'm going to use TonScan Explorer, and of course on the testnet. You can go to the root domain to actually work with the real blockchain, but this is a testnet version. And I will need the address of our contract to put it here. So I copy it. And voila. So last activity, 1 minute to go. And interesting, we just deployed a contract, but we see so many transactions here. What is this? As I mentioned before, the address of the contract in Tony is determined. So we know the address, and it consists of the code and data. So basically, if I'm deploying this contract and it has some code and data, and you are deploying the very same thing, so if you follow steps same as I did, and you will deploy the same code and the same data, the initial state of the contract, your contract will have the same address. But the thing is that they are not different contracts. There is no sense to store two different contracts with the same code and same initial data, because they would have the same logic. There is no difference. So once you change the initial data or you change code, you're going to have completely different address. And this is not bringing any vulnerabilities, because you would want to have any significant logic, let's say administrative address, like who's the admin who can withdraw money, for example. You would want to have it inside of the initial state data. And thus, you would actually have your different logic, and no one would actually need to deploy the same contract. So basically, what happened just now, I didn't actually deploy a new contract, because I've done this with this code quite a few times, and you can see that our most recent transaction is here. So if these transactions wouldn't be present there even, the contract will be still deployed, and you would actually have it just the first transaction, and you just have the same result. So congratulations, you have your first deployed smart contract. But why don't we do something more? So once the contract is already on the chain, let's make some test that the functionality works as expected. So let's create a post-deploy test. To create on-chain test after we deploy the contract, we will need to create another script, of course. And an important thing that we will need to do is we will need to use some connection to the blockchain. So we send a message with our Sandbox application, but there is certain RPC nodes that you could actually read data from the blockchain through the centralized API. So basically, our script would connect through some endpoints that are actually having the blockchain on them, and ask these endpoints for certain data. So we could actually, for example, check technically in code, is the contract deployed? So let me create a new script in package.json, in scripts folder, and then we will declare it in the package.json. We'll call it on-chain test. And then in the package, we're going to have new script, on-chain test. We don't need to compile because it's already deployed. It has nothing to do with deploy. Yes, we're going to run it like this. To check if the contract is deployed, we need to calculate its address again. So it's going to be called on-chain test script. And we execute it. So here we will do something that we did quite a few times already. It's very familiar. We are taking the code, importing the code. We are actually creating a new empty cell with data, because our initial data doesn't really matter for now, but we're going to get back to it very soon. From build, and the file is called, I guess, main compiled. Okay. Build. Main compiled JSON. Great. And we, of course, need the function to actually calculate the contract address. Awesome. So let's install the library that we're going to use to connect to some RPC node to read from blockchain. And the coolest one out there is called Ton Access. It is made by Orbs team. Very good team, and building a lot of tools for Ton. And we will learn more tools from them. But now we just installed this library, and let's learn how to configure it. So basically, we'll import a function that will actually get us the endpoint. So this is a decentralized RPC. So we might have different endpoints at every moment of time, at every running of the script. So that's why we use this function, and it happens under the hood when we get the actual endpoint to which we need to connect. And this is how we connect. So we actually we use this function, we say that network should be testnet. Of course, we will need to change this for production, for mainnet. And we will need to import one more, Ton client v4, yeah. This is a class that we take from the Ton library. And this is the type of, let's say, protocol that the way we read from the blockchain. So there's a few types, but we don't have to learn about all of them for now. The most popular one is this Ton client 4. And we will actually learn more about it in a moment. So, and then we are proceeding with latest block. So basically run a function get last block. So we understand that we want to get an account state. Account and contract, these are synonyms. So basically we want to get the state of our contract at the moment of latest block. So this will ensure that we took the proper state that it's right now. So we get the last block and we check the status. And we, of course, can console that if the status account state type, if it's not active, then we say that contract is not active. We cannot run on-chain tests, obviously. So let's now get to the actual test. So we're going to create a link for a simple transaction that will send 1 ton or less or whatever amount that will send it to our contract's address. So just like we did during writing tests, and just like we did on deploy, we can actually create a QR code that we will use to scan it with Sandbox. So as you remember, the logic of our contract, we actually want to send some message into the contract, and then we want to check that the most recent sender is actually our address. So let's generate this link. So again, we use the link that is going to redirect us into the Sandbox app. We have to import the 2 nano. I will send less money. I don't need to send this much. And of course, I need to import the QR code thing. Exactly. So we're good. So we basically just send some money into the contract. And so immediately after showing the QR code, our script will start invoking getter method of the contract to actually get the latest sender address, once it changes. So we don't want to actually console log the same result. We actually remember this recent address, and then we check if it changes. So we will have to import a few more primitives. And our code will look like this. So recent address archive. So let's say this is going to be called archive address. We have to import this class from the Tone core as well. And now we create an interval. So this function will repeat every 2 seconds. And then every time we perform a check, that we need to get the latest block sequence number. So again, we get the last block. And then we're using run method of the same client for, because this is the client that we're using to read from the RPC, and we can actually run a getter method from it. So, and then we put the name of so we take the last block sequence number, we take the address of the contract, and we take the name of the getter method. So we actually want to check the exit code. So we're using run method to call it, and the result, one of the results that we're getting is the exit code, and of course the result. So we make sure that script stops if the call was not successful, or if the data received is not of type slice. So as you can see here, we're actually want to make sure that the type of the data is a slice. As you remember, address is stored as a slice. So if we get any other result from here, we just stop it because we know it's just unknown. And the sweetest part, we actually get the most recent sender. So we take the 0-18 stack, we take its cell, and we parse it, because the result is given us as a cell again. So we begin parse, and then we load address. We use this method to actually load it. So then we check if most recent sender is available, and most recent sender, the string version, is not equal to the archive version that we have here just as an empty. Then we say new recent sender was found. And then we basically save the result here. So this is the logic, and we would need to just run it now. We get a QR code for a transaction. I'm going to scan it. So currently, this is the address that was the most recent one. And now I'm going to send money to this contract from different address. So I will log out from Sandbox application that I have now, and I will create a new wallet, top it up with testing Tone coins, and I'm going to send a transaction to the same contract, but from a different testnet address, and we're going to see that it's going to change. So I'm having a new wallet with some testnet coins, and I'm going to scan the QR code and send this amount of money that we requested, simple test transaction. And we are going to return to the Explorer, and we can see that there's some error. Yes, it was basically just a timeout of the RPC. Things like this happen. Let's run the test again. But now we will actually, we didn't remember the address somewhere in database, so it's obviously is going to vanish. So we will just need to restart our script. It's connecting to the RPC node. And again, we see the QR code. It's having this address. Actually, because our connection to our PC node failed, we don't remember here. So here is the last sender that was found. So let me now send another message from different wallet with different address, and we will see how it will change here. Once the transaction is confirmed, we will see in real time how the most recent sender just changed. As you can see, there is a new most recent sender. So our code is working. In the next lesson, we are going to learn how to actually deploy to mainnet. So we are going to deploy the contract to mainnet as well. And we are also going to learn how to use our script that we already have now, the custom one, how to use it to have multiple scripts here in the package JSON to deploy to testnet and mainnet and run on-chain tests separately on testnet and mainnet. So this would be a better understanding for you how this could work.